To find two angles that either add or subtract to be 105. Two angles on your unit circle that add to give you 105 or subtract to give you 105. Make sure you take out your pink sheet and your unit circles. So there's a lot of different options that we could do. So how do you want to get to 105, Jaden? 135 and 30. So we're going to subtract. Okay. So we're going to do the sum difference. And we're going to do the sine of 135 minus 30. Now, if somebody was thinking, well, no, I was going to do 60 and 45 and add them. Same thing. You get the same answer. But the first person said subtract, so that's what we're going to use. The bigger angle would be alpha. The smaller angle is beta. So I'm using this identity because I'm subtracting. So in this identity, any place where you see a little a, I want you to put 135. And any place where you see b, put 30. So we'll have the sine of 135 times the cosine of 30 minus cosine 135 times the sine of 30. And again, when you see this on the test or on the skills check, as long as it either adds to give you 105 or subtracts to give you 105. So now we need to go to our unit circle and find these four values. Now, with the skills check, if you got a 20 out of 20 on the first one, because you know I dropped one of them, then theoretically it doesn't matter what you get on the second one. However, I would still encourage you to try your best, because that way you get a chance to practice more questions that will actually be on the test. And you can get feedback from me to see what it is you don't know. Okay, so what is the sine of 135? Sine of 135 is positive square root of 2 over 2. So I'm going to put that here. What's the cosine of 30 degrees? Then we go to the next one. We need the cosine of 135. That would be a negative. And then we have a 1/2. Okay, so now let's multiply. So when I multiply these together, I get the square root of 6 over 4 minus, now I'm going to multiply these together, and that would give me a negative root 2 over 4. And what happens when you subtract the negative? It changes to what? Positive. So your final answer would be root 6 plus root 2 over 4. And that would be what I'm looking for. Any questions? So we're going to finish 7.5 today, and we're going to do the sum and difference with tangent, which if you look at the identity, everybody look at your pink paper. Notice that tangent is the one with a fraction in it. It's the one that requires a lot. So let's go ahead and do that. Here are your two identities. Again, you don't need to memorize them. So take a minute and copy this down. So we're going to do the sum formula. So I feel like radians are a little harder to figure out because, you know, they're fractions. So what I do is I focus on the numerator and I start to split it up. So I know that 1 plus 6 is 12. Here, let me go back a little bit. It's kind of... So I know that 1 plus 6, 1 over 12 plus 6 over 12 would be 7 over 12. But can I use that as an option? Because they both need to be on the unit circle. Now this is on the unit circle because this reduces to pi over 2. But is there a pi over 12 on our unit circle? All right, so that's not going to work. So I'm going to take off that 1 and 6. Now I'm going to say, well, what about a 2 and a 5? 2 and a 5 give us 7. So we have 2 over 12, which will reduce to pi over 6. Is that on our unit circle? Do we have a 5 pi over 12 on our unit circle, though? No. Okay, so that didn't work. So then I'm going to go to the next option, which would be what? 3 and 4. 3 over 4, what does that reduce down to? Pi over 4, which is on our unit circle. And what does 4 pi over 12 reduce down to? Which is also on our unit circle. So we got our two angles now. So we're ready to go. Now, the one thing I want to point out to you is that this identity does not use sine or cosine. It only uses tangent. So we have to figure out before we do anything else. Well, first of all, which one is bigger? Pi over 4 or pi over 3? All right, so we need to find, so we're going to take the tangent of pi over 3 plus pi over 4. So before we do anything, we need to find the tangent of pi over 3, and we need to find the tangent of pi over 4. So in order to find tangent, how do we find tangent from the unit circle? Y over x. So let's look at pi over 3. So we're going to take the sine and divide that by the cosine. So I'm going to take this off and put it back in a minute. So what is the sine of pi over 3? So we have root 3 over 2 divided by 1/2. How do you divide fractions? So that would be root 3 over 2 times 2 over 1. This cancels. And I'm left with just the square root of 3. So I figured out that in this identity, the tangent of pi over 3 is going to give me root 3. And this is my alpha angle because it's the bigger one. So we got to do the same thing for pi over 4. Now that one should be a lot easier though. So to find the tangent of pi over 4, again, we're going to take the sine divided by cosine. So that would be root 2 over 2 divided by root 2 over 2. I shouldn't really need to go any further because this is one that tangent is pretty easy. What is the tangent of pi over 4 going to be? 1. So we got that. We know tangent of pi over 4 is 1. So this is all of the work that we have to do with tangent before we can even approach the identity. Now that we have all of this background information, we're ready to use our identity. So every place in this identity, because we identified that this is alpha and this is beta. So every place where it says alpha, tangent of alpha, we're going to put a square root of 3. So we're going to put it here and we're putting it here. In any place where it says tangent of beta, we're going to put a 1. So that would be here and here. So what I have is, now I'm ready to go. I have, so the tangent of 7 pi over 12 is going to be the square root of 3 plus what? What's the tangent of beta? 1. That's all over 1 minus tangent of alpha times tangent of beta. So that would be root 3 plus 1 over 1 minus root 3. Now, if you made it to this point on the test, I would be so proud of you. Like, I really would. But I would not give you full credit because there's something wrong with this. We cannot leave a radical in our denominator. So what are we multiplying by? We actually have to multiply by 1 plus root 3. It's called the conjugate. So what I want you to do, whichever way you choose, you can FOIL, distribute, make a box. Jaden, I hope you with me over there. Okay. So you're going to multiply these two together, make a box, and you're going to multiply these two together. So I'm going to give you a chance to do that. So we have, I'm going to do my numerator in red. So I have the square root of 3 plus 1 over 1 plus the square root of 3. That's the numerator. For nope, it shouldn't matter. Nope. So we got square root of 3 in this box. We got a 1 in this box. Okay, this is the tricky box. What's going to fall in this box? What do you get when you take a square root of 3 times the square root of 3? Just a 3. Because 3 times 3 is 9, and the square root of 9 is 3. So we have just a 3. And then we have a square root of 3 here too. So when you combine your like terms, I'm adding these two together, which is like saying 1x plus 1x. If I said what's 1x plus 1x, what would you say? 2x. So 1 root 3 plus 1 root 3 is 2 root 3. All right, now we're going to go the other direction. Let's add these two. And that's easy. 3 plus 1 is what? All right, so we got our numerator. We're going to let that cook on the stove. Now we're about to go over to our denominator, see what that looks like. So our denominator, which is the whole purpose of doing this, because we should not have a square root when we're finished. So we're going to make a box. And you're multiplying 1 minus root 3 times 1 plus root 3. So go ahead and fill in your 4 squares. So this is what you should have in the second box. So this is, again, this is like saying negative x plus x. They cancel. You get 0. So this goes away. And what do you get when you add these two? Negative 2. So that would be my denominator. So now I have the pieces. I'm ready to put them together. So my answer for the tangent of 7 pi over 12. I have 2 root 3 plus 4 over negative 2. And if you gave me that answer, I would only take off half a point. It's really good. It's not great, but it's good. Anybody know what else I should do? Yeah, you should reduce. If you can reduce, you should reduce. Always reduce. My class of 2025, if you choose to go off to somebody college, make sure you're reducing. So we got to do 2 root 3 over negative 2. I'm just splitting my fraction apart. So my final answer would be a negative root 3 minus 2. Now this answer, that's 5 out of 5. I know tangent is like the cousin that don't nobody talk to because they do too much. Like tangent is doing too much.
So with that answer, like the 2 root 3 plus 4 over negative 2, again, 4.5 or something.
4.5 out of 5. Yeah, that's good. That's why I say that's still good. Any questions? What did you say one more time, Tamaya? Yeah, I reduced. So what I did was I divided these together and I got a negative 1. I just didn't put the 1, but it's a negative 1 right there. And then I divided these two and got a minus 2. All right, one more. Let's go ahead and copy this down. Now, I think we should work smart and not hard, okay? We could do 45 minus 30, or we could do 60 minus 45. If we want to stay in the first quadrant, which I would. But we already did the hard work in the last example with 60. Okay, so personally, I would use this as my pair. Because I already did in the last example, I already found the tangent of pi over 3 and the tangent of of pi over 4. So why go back and redo something? We don't have to. So let's use that. Oh, okay. So we got the tangent. And then pi over 3 minus pi over 4 now. We're using that identity. Now we know that the tangent of pi over 3 was what? What did we get for the tangent of pi over 3? Root 3. And we also know that a tangent of pi over 4 is what? So we don't have to go back and do that. If we use the 45 and 30, then I would have to figure out the tangent of 30, which I'm going to tell you is a fraction, and then that would be really ugly because the tangent of 30 is root 3 over 3. So then we would have a fraction divided by a fraction in a fraction. It would just be too much. So let's just be smart about this. We know where we got to go. We already did the hard work, so let's just do it again. And our answer is, this is just for your practicing purposes. So every place where it says tangent of alpha, we're going to put root 3. And every place where it says tangent of beta, I'm going to put a 1. So tangent 15 is going to be root 3 minus 1 over 1 plus root 3 times 1. So we end up with square root of 3 minus 1 over 1 plus. So what do I need to multiply by to get rid of the fraction? 1 minus. So I'm going to let y'all do that. Go ahead and do that. Make 2 boxes and multiply them both. So we should have a root 3, a negative 1. This is going to give us a negative 3. This is going to be a positive root 3 because we're multiplying a negative times a negative, which gives us a positive. So for my numerator, I get 2 root 3 minus 4. Who had that for their numerator? All right, good. Now let's do our denominator. So we got a 1, we have a square root of 3, we have a negative square root of 3. And then what goes in the last box? What's negative root 3 times positive root 3? 0? Do it again. This last box. It's negative 3 because you get negative square root of 9, which is a negative 3. This cancels out because they're opposites, which is what we were trying to do. And when we add these two together, we get a negative 2 for our denominator. So now we have our pieces. We're ready to put it together. So my answer is 2 root 3 minus 4 all over negative 2. You got your 4.5. If you stop here, you did great. I'm proud of you. But I'm still taking off half a point because we should be reducing our fractions. So you should break it apart. So reduce both of those fractions to get the answer to give you full credit, and that would be a negative 1 root 3 plus 2. This is 5 out of 5. Any questions? All right, that's the end of 7.5. So now let's go to 7.6. So 7.6, go ahead and title your notes. So 7.6 is double and half angle. So if you're titling your notes, so I'm probably going to add something to this page. Different things. All right, we got our notes titled. We ready? 7.6, double and half angle. So we're on the pink sheet still. So after sum and difference is double angle. So that's what we're going to talk about today. And we're almost done. And this is what I'm going to do tomorrow. On Teams, I'm going to continue in double and half angle identities. All right, so okay, so these are our identities that we're going to work with. Today, we're not going to mess with this. We're only going to focus on our double angle. But this is what I want you to notice about the double angle. They gave us 3 options for a cosine. So if they ask me for a cosine double angle, I have 3 choices. There's only 1 choice for a sine double angle and 1 choice for a tangent. Okay? So that's really important, that it doesn't matter if you're doing a cosine double angle, it doesn't matter which one you choose to use, you would get the same answer with all 3 of those identities. All right, go ahead and copy down this example. We're going to do a cosine double angle and we're going to do a sine double angle. So we're going to do 2 things. We're going to find the cosine of 2x, and then to Maya, on yours, I only did the sine, but I'm going to do both. So we're going to find cosine double angle and sine double angle. Hi. Thank you. Thank you so much. Osmel, you got to pass.
Is that a 2x next to the sign?
Yep. And the reason I put a 2 is because if you multiply something by 2, what are you doing?
Minus
doubling it. Okay, so I want you to notice when you take the test, it's not going to say use the double angle identity. You have to know it's asking you for double angle because it has the angle multiplied by 2. It's asking me to find cosine 2x. And if you multiply by 2, you're doubling it. All right, so we got the only thing they gave us is sine. And fortunate for us, we have an option that only uses sine. So this is the one I'm going to work with. So I'm going to do cosine of 2x equals 1 minus 2. And it's sine squared. And what did they say sine was? 4 over 5. And now you're going to do order of operations. So according to order of operations, what comes first? Parentheses. So we don't have anything in the parentheses except for a number. So next would be E. And what does E stand for? Exponent. So we need to square 4 over 5. So you need to take 4 squared over 5 squared. What is 4 squared? And 5 squared? All right, now we're almost there. So now we got 1 minus. I need to multiply this by 2. So again, still no calculator, but 2 times 16 would be what? 32. Okay. So now we got 32 over 25. Almost finished. What do you have to have in order to add or subtract fractions? So instead of writing this as 1, I'm going to write this as 25 over 25. Do you agree that 25 over 25 is the same as 1? So now we're ready to subtract 25 minus 32. And my final answer would be cosine 2x equals negative 7 over 25. And that is our resting place. All right, last thing we're going to do is find sine double angle. Does everybody have that before I take it off? Anybody need more time? Okay, so now we got to find sine double angle. Now, sine double angle, we only have one option. And to find the sine double angle, I have to know cosine. Because it says take 2 times the cosine of x times, well, it says sine first. Let me go back. It says 2, this is what I'm using right now. 2 sine x cosine x. So I need to find cosine. Any ideas how I can find cosine? Cosine 2x, not the same as cosine. Nope, can't do that. So what we're going to do, going back to the last test, I think, we know that sine is y over r. And we know that x squared plus y squared equals r squared. So we need to find x. Because cosine is x over r. Yes. One more time. Yes. So you can use any. So if you look at the pink sheet, notice they put a theta. That I got that offline. They put a capital A. You could put an X. You could put a S for Sean. You could put a C for Clinton. You could put a T for Tamai. You could put whatever you want to put. Okay. So we got x squared, which we don't know. And you might already know what this is, because this is a Pythagorean triple. Yep, it is 3. Like, I would not personally do all these steps. But if you don't recognize that 3, 4, 5 is a triangle, then by all means do that. Subtract 16. So we got x squared equals 9 and x equals 3. So now I can figure out that my cosine is 3/5, but we're not finished. And I need to clear this up with fifth period tomorrow. We're not finished because they gave us a quadrant. So let's go back to the beginning. Right here. Show me with your fingers what quadrant you think we're in. Pi over 2 to pi. Is cosine positive or negative over there? In quadrant 2, is cosine positive or negative? So we have to make this a negative 3/5. So the cosine of x is negative 3/5. So now we're ready to do our double angle. So I have the sine of 2x equals 2 times the sine, which is 4/5, times the cosine, which is negative 3/5. This is a lot easier because we don't have to square anything or subtract anything. All we're doing is multiplying straight across, and you're done. So you're going to take 2 times 4 times negative 3, that's your numerator, and 1 times 5 times 5, and that's your denominator. So what do you get? What's 2 times 4 times negative 3? Negative 24. What's 1 times 5 times 5? 25. So that would be your sine double angle. We're going to pick up here tomorrow on Teams.